Alright guys, you know the drill, round 3 of 3. This one is much like the other one in that there's only one master-slave socket, but it has the extra power out. How about that? Let's get it open, no messing about. Alright, stand back. This could blow. You muppet. Ah, so this has the old controller board with the socketed micro, and quite likely a dead power brick. Plugging it in, and we'll see if we can't get a voltage measurement. I don't see any point in even trying. So there's no lights on the back. The numbers aren't lighting up. It's clearly a bad power supply. Clearly, surely, deeply, madly. Let's just shove a probe down in there. See if I can't probe each one and see what's going on. Don't forget to mix up your polarity. Hey, look, nothing at all. This could be the same fault as the last one. And I was hoping for 3 different faults. And the big reveal. Nothing out of the ordinary. But I did check, and I've got another one of those startup caps. 10 mic, 50 volt, does the trick. Watch your fingers, we're going in hot. Now we should expect to see, there's our little capacitor there. And we're looking for a voltage that is at least, what, 12, wasn't it? 8 volts. Once again, it cannot form its voltage to start up. New cap in, forgot to show you that process, but you can see it in the previous video. Let's see if it works, I suppose. I can show you that. It would kind of be pointless if I didn't. And a 1. And a 2, and a, are you focused? And a 1, and a 2, and a, okay, still not working. Hey, maybe we do have a third fault. What did I miss? I know I didn't put that cap in backwards. Let's see, check our voltages. We want to check on that one and that one. 15 volts, so this thing should be running. We have a bigger problem. What is our bigger problem? The meter's going to turn itself off, that's a problem. We have, oh look, we got 12 volts on the output, so we have a fault on the other side. Cool, we have a different fault. Looking at the board, we have a pretty straightforward layout, I guess. And what appears to be on this heatsink is a 7805 regulator. First of all, we need to find out if we have our 12 volts coming in. Pretty sure it's down the end here. So let's check that. That goes through a, looks like a 5 watt resistor and into our 5 volt reg. Make sure nothing's touching the chassis that shouldn't. Plug it in. Checking for our 12 volts in. There we go, 12 volts. Checking for our 12 volts on the input to the regulator. I'll be measuring this point here. Well, I might as well check before the resistor, which would be there. Where is it? No, there. I'll check into the resistor, is going to be there, and then after the resistor, which goes into our regulator, and then after the regulator. So into the resistor we should have 12 because it's just a straight trace to it. After the resistor we should have 12, we do. After the regulator we should have 5. And we have, oh, 0.8. 0.8 of a volt after the regulator. So no, that's no good. That is no good at all. Is it getting hot? It's not getting hot. Must be either, maybe it's in some kind of shutdown mode. Let's remove the power. Make sure we're discharging. Yeah, less than a volt. So we have nothing coming out of the rig. Do we have a low resistance that could be pulling it down? Let's check from there's a capacitor here on our input. So that's our negative on the capacitor to the positive side, which is our output of the rig. So that's, oh yeah, 2,500 ohms. That tells me it's probably a bad regulator. If this cannot create 5 volts, there's no overload going on there as far as I can tell anyway. It looks like the LEDs are all driven off the 12 volt side, so the 5 volt is only used for the processor. What we can do is let's put 5 volts on our bench supply on here, and we can see if it comes to life, and that will prove that there's no other fault. Maybe when the processor or one of the other chips get power, maybe there's a short that develops after that, but I doubt it. Hopefully we see this light up. Power on. Hey, hey! There we go. And does it respond? Yes. Cool. We need a new 5 volt rig. That one's loose. Is that one loose? Where is those pliers? Let's get the tweezers on it. Might be safe a bit. Barely got a chance to get it wet and it popped off. I don't have a rivet gun. I don't think I have a rivet gun. This is riveted on, so I'm going to have to find a little screw to mount that to the heatsink. But in the meantime, let's just pop one of these on and we'll see if it actually works. So we'll flip it backwards and tack it on there, just as a trial run. all attached. That'll do us for a quick fire up. Just let it cool down slightly because it's a bit hot from being soldered. And do we have a power? Hey, there we go. Failing power supply probably sent bad DC down the line and killed it. To remove a rivet, you need to securely mount the thing in the vise. Now I've cut the legs off so that we can do that. Clamp that there. In fact, I might even just put it down there. So, there we go. So that's down against the bottom of the vise so that I can push on it with the drill and it won't slip out of the jaws. Much better idea, isn't it? Now, you can hold this in your hands if you want to lose a couple of fingers. Get a drill that's about the size of the rivet and away you go. Drill the head right off and the rivet will just pop out the other side. I'll take this one back off. And I think I have a screw that will be suitable for that. Always save screws from things you disassemble. You never know. Now I'm going to put some white heat transfer compound on there, because why not? Why not give it a shot? Give it a little bit of a chance to last a longer life when it's in something with very little airflow. Not that it probably should be getting that hot at all. Just the tiniest blob. Is it square? It'll go in the holes. If you're unsure, or if you've done something like that, that you'll be able to sit it back into place, you can always dummy fit it on the back side of the board, and then you'll know that if you're trying to get it down in a tight space, if it lines up there, it'll line up on the other side and you won't have a headache trying to figure it out. Now we just need a little bit of solder to tack it into place so I can let go and fully solder the remaining legs. Reassemble! Why is there such a bend in the board? Holy moly! Well, that's not flashed. I've got 3 standoffs holding this board on, and kind of skew whiffing the shape of it. Oh, that's looking promising. Let's see and check the front side and make sure that they all work. There we go. We have all green. We have all blue. No, we're missing some blue. Oh no. And a couple down the end there as well. Oh dear. Can't win. Well, maybe maybe take some LEDs out of this one to fix the other one or something, but whatever. It is what it is. And once again, we turn trash into working trash. Well, thanks for watching along. Hey, we got our 3 different faults. That's what we wanted. 3 different faults out of 3 same items. How cool is that? If you liked it, give it a thumbs up, subscribe, stay tuned for more exciting, generic electronics repair.